Good morning, students. In my earlier video, I told you that cell membrane monitor what goes in and out of the cell. So, how does they do that? How does the movement happen across the membrane? Now, the transport across the cell membrane can happen in following ways. The first one will look into diffusion. Let's say that I have this container, and inside this container, I have some air molecules. Now, the air molecules, the, they are all going to have different velocities. They are all going to be bumping around in different ways. So, this line here is an imaginary line and it has no structural significance. I am just using it to divide them to visualize the left and right hand sides. You see, on the left hand side, I have a higher concentration of my molecules. And how do you measure concentration? Well, the number of molecules per unit area. Suppose if I take a cross section that large, look, I got 4 molecules here. Well, if I took a same size section on the other side, I'm getting only 1 molecules here. But so we have higher concentration on the left and we have lower concentration on the right. And when you have this situation where you have a higher concentration and then a lower concentration, we call this a concentration gradient. Now, what do you think is going to happen? Well, this all of these particles are going to be moved from left to the right as we have more particles on the left than we have particles on the right. As time goes on, it's going to look something like this. If we let enough time go by, we see that we should no longer have a concentration gradient. I have no gradient, and there's nothing magical here. You just have to think that these are all just randomly bouncing around, and if you have a higher concentration on the left, there's a higher chance that you have things moving from the left to the right. But now that you have the same number on both sides, so at any given period of time, you have an equal probability of things moving from the left to the right as you do from the right to the left. So you are getting to this kind of equilibrium situation. I only did this with few molecules, but there are different types of molecules which tries to enter or exit cell membrane. So this process that we describe, this is diffusion. We will see that this is actually very important to biological systems and even chemical systems because this doesn't require any extra energy to move the molecules from here to there. So it's going to happen naturally. However, it can still move from the right to the left against their concentration gradient. Now, what's interesting about this diagram is I have introduced a second particle, this big purple particles, and we see that their concentration gradient is going in other direction. So we have a low concentration on the left hand and we have higher concentration on the right hand side. So their concentration gradient goes from right to left. And the whole point of the concept was to show you that each particle moved down its unique concentration gradient, that is from higher concentration to lower concentration. Now, another way of transport across the cell membrane is through osmosis. So let's see what's osmosis. So let's say that I had two compartments of water and they are separated by a semi-permeable membrane. So now, and here this line is a semi-permeable membrane. So now what do I mean by semi-permeable membrane? That means they allow something to go through and not other things. Let's say the semi-permeable membrane, it does allow water molecules to pass. And in a few seconds we will talk about what it does not allow to pass, which makes it semi-permeable membrane. Let's just think about what would happen if we just had water molecules on both sides. We have already talked about it in diffusion. The water molecules, since we have an equal concentration on both sides, the probability is that the water molecule goes from left to right and right to left is equal. And that's because we have equal concentration. But now let's make this interesting. Let's treat our water as a solvent and let's put some solute in it. So let's dissolve some solute and I am going to make them bigger like this so that you can see they would physically have trouble passing through these gaps. I'm going to do many more over there on the right hand side. So we have higher concentration of solute on the right hand side. You can see from the size these big particles aren't going to be able to go through the membrane. If they were allowed to diffuse, then they would just go down their concentration gradient, and after a moment of time you would have a higher concentration of these big particles moving from right to left than from the left to the right, cause you just have more on the right hand side. But this is semi-permeable membrane. These things aren't just going to be allowed to naturally diffuse. So what is going to happen? We know that the big particles can't diffuse from one side to another. But what's going to happen to water molecules? They are not going to be stopped. They can bounce from the left to the right, or they could move from the left to the right through one of these gaps. But what about the one on the right hand side? If they were in the right condition, they will move from right to the left. But in here, it does not happen like that. The one on right hand side has a lower probability of water molecules from right hand side moving to the left. And why is that? So there all this interference that play from these big molecules that aren't able to diffuse. They are going to be blocking the approach to these openings. If this membrane wasn't here, they wouldn't block the approach. They would just keep on going. But since that membrane is here, they might block some water molecules. Some of them will still make it from right to the left, but you have a lower probability of going from right to left as you have from going left to right. So because of this, you would have net inflow of water from this area where you have a low solute concentration. Remember, solute is the thing that dissolved in the water, and solvent to be whatever there's more of, and solute is whatever less of. So in this case, it's water, and water is most typical solvent. So the solute is dissolved in the solvent, and so we have a net migration of the water molecules from this solution that has a low solute concentration to one that has a higher solute concentration. So this phenomenon we call osmosis. We call this osmosis.